Hello everyone. So today in this video we are going to talk about how to set up the Moose framework, and we're gonna discuss the entire workflow from what we need to run an input file, what we need to modify an input file, to what we need to visualize the results once we run the simulations. So first, just a brief background about the Moose software. So Moose is an acronym for Multi-Physics Object-Oriented Environment Simulation, and it is basically a high-level finite element solver, although there are some additions. So now we also have the option to use finite volume. So both finite volume and finite element are very robust and popular numerical methods for solving partial differential equations. So it is a framework or a computational framework to basically solve multi-physics problems. We usually use coupled partial differential equations to model multi-physics problems. And Moose is a very popular open source computational framework for that purpose. It was introduced back in 2014. In the same year, it won the prestigious award of R&D 100. It's completely open source, and you can basically get it directly from the Moose website or GitHub, as we will see and discuss in a few minutes. So in general, basically Moose is a robust and a sophisticated software. So it has a lot of or several libraries and dependencies. The main structure is basically we have a Moose is built on some infrastructure that is basically the mainly Betsy and libmesh. So libmesh is the finite element library that give you options to basically use different types of elements, structured or unstructured, and different approximations for the shape function and things like that related to the solution of the finite element. And Betsy is a solver, a very robust nonlinear solver from developed by Argonne. And then Moose itself has its own infrastructure also that we call the main framework that has some built-in capabilities. But what set Moose different from many of open source finite element solver and framework that it has its own built-in physics modules already, where basically some of the main known equations and some quantitative laws and things like that already implemented, and you can just basically call them very much like call them directly in the input file, very much like when you use Mathematica and MATLAB or even Python and basically call some functions or some capabilities that's already coded. And also Moose has the ability to be used as API, basically application programming interface. You can build your own application upon Moose. So this is very common and popular in basically nuclear engineering, where basically there are many programs that are compatible or built on Moose. But also it's now being expanded to several other uh, engineering and scientific majors where basically they make their own applications based on Moose. So what we mean by those physics modules, so basically something like heat conduction or heat transfer in general, some solid mechanics, some microstructure evolution that using the method with a Fies field. So in all of those physics, there are very common and popular models that models will usually consist of coupled balance equation and constitutive laws. And basically, some of those are already implemented such that you can directly physically utilize those models. So in kind of basically a plug and play kind of way. So Moose tries to basically be as relatively easy to use as basically some of commercial software like ANSYS and Abacus, but still, of course, it's not 100% graphical user interface. So you still need to learn how to interact with it and how to basically uh, understand and make the input files and modify the input files. So you still work basically in a research and development mode through terminals, but it lies in this nice spot in between where basically you don't need to code everything from scratch every time you want to do something or simulate something. And at the same time, you don't just basically use a pre-existing graphical user interface where basically everything is kind of like a black box where you don't really know what's going on. And also for the sake of research and development, so it's not just an engineering software. For research and development, you can modify it and you can add to it and you can change it and you can run it either on your laptop or desktop using a few cores, or you can run it on clusters using thousands of cores. And of course, it's open source and free. So something like heat conduction, you can solve it in different ways. You can use different models. You can account for microstructure and things like that. Same with solid mechanics. You can run models that simulate the elastic behavior or plastic behavior or elastoplastic behavior. So it has a lot of models and capability already built in. So to understand the framework, the main thing that we need to keep in mind is there are three basic cornerstones of the workflow where you can utilize or read or modify an input file, run it, get the output, and basically visualize the output. So to do that, we need three different things. We need to basically set up the VS Code, which is basically a code editor that we can use to read and modify the input files. And we need to set up Moose, where basically we use the Conda environment to set up the Moose package. And then eventually we will need ParaView to visualize the output. So ParaView is a very powerful visualization software that can be used to basically visualize the output of Moose and many other software. So just one important note to keep in mind is Moose, very similar to other open source packages and software, was meant to basically natively run on Unix-based operating system. So that's something would be like Mac or Linux. So for those who have such machines, then you can directly go to the first step, which is setting up Moose. However, if you have a Windows machine, then we will need to basically have an extra or a prerequisite step where we need to basically enable the virtual environment that is known as Windows Subsystem for Linux. So this allows us to run basically a Linux, utilize a Linux terminal from inside the Windows operating system. So to do that, however, it's straightforward. So again, this is just to summarize the three different steps that we are going to do to basically set up the entire environment. Again, if we have a Mac or Linux machine, then we can directly go to the first step. For Windows, we have to do this basically prerequisite step of enabling the WSL. So to do that, however, it's straightforward. So basically you go to the control panel. So let's go over this quickly. Let's see if we can do this quickly from here. So basically I have already done this, but I will just show you what we are basically trying to do. So you will basically go to control panel and then From control panel, you can always enable or disable some Windows features. So you will go to it's under programs, yes. So from here we will turn on those WSL features. So there is a virtual machine platform. We'll have to check this box. And basically, I have already done that, so I don't need to do that again. And then basically for the Windows subsystem for Linux. So those are the two things that you need to check if you haven't done this before. Once you do that, if it's the first time you haven't done this before and you click OK, it will ask you to basically restart your computer to enable those features. So once you do that, you have successfully enabled the WSL. Then you will go to the Microsoft App Store and get the Ubuntu, which is basically a distribution version of Linux. So usually the older version, the 20.04 is the most stable, but however, usually most versions are fine if you just use Ubuntu. So I have both of them are installed on my machine. So I have the older version, which is usually I recommend this is the most stable for almost all the applications. But however, in many cases, we have seen all the students installing the recommended or the version, the most recent versions that Microsoft keep also should work fine. So either you get the basically the Microsoft up-to-date version or get the most stable one, the 20.04.6. So this is just an app from the Microsoft App Store. So you will basically install it in a similar way. Once you run it the first time, however, you will be asked to initiate a Linux username and a password. Those don't have necessary to be the same as your Windows account. And once you do that, you will basically get a Linux terminal or a shell window that will have basically your username at Ubuntu. So once you reach this step, and then you have basically a Ubuntu terminal running on your WSL. So just to make sure, you wanna see that basically, so the terminal will look something like that. So WSL, you can always, if you're not sure whether you are in, so it will have this, what we call the base environment, and I'm gonna talk about that in a minute, and then your username. Even if at any time by mistake you opened a Windows terminal or a Windows shell instead of a Linux terminal or a WSL terminal, you can always type WSL to go to a WSL terminal. We're going to see in a minute that once we also set up the VS Code, we can work on terminals from inside the VS Code itself. So the next thing is basically, since we are working, we just installed Linux, you can also at the same time, since you hopefully still remember your password, you can basically add MPI capabilities. So basically to run simulations in parallel, basically we use the message passing interface protocol. So this is not usually enabled by default in the Linux application and WSL. So you will have to basically enforce that. So you will follow those two commands. It's better to type the commands instead of copy and paste. But however, those commands are straightforward, should be fine. But in general, we're gonna see that later in this presentation that basically, if you copy and paste, you wanna make sure you're not adding basically any extra space or changing basically In some cases, it was adding any metadata or extra space or invisible characters. So this could happen when you copy and paste from a file to a terminal. And also enabling MPI would also be required even if you have a Mac. So in this case, you will the command would be different, but basically you will still need to enable that. Now, a very nice editor that we can use to basically really edit and modify different types of codes and input files is Microsoft own Visual Studio Code. So this is also an app from the Microsoft store that you can get. So you can just directly again go to the Microsoft store and look for VS Code. Yep. That's how it looks like. So I have already that installed, so I don't need to install it. So we can also kind of improve the workflow of the VS Code by basically making it able to see our Ubuntu or our Linux subsystem basically by default, because in many cases, especially when we are using Moose or software like Moose, we are running things from a Linux terminal. So we can do that by basically inside the VS Code, you can look for the WSL extension. And once you enable that, you will basically be able to, every time you launch the VS Code, it will always recognize that basically you have a Ubuntu subsystem, and it will basically give you access to that terminal directly. So the way you do that, so after you do that, you will see something like that, and that's why the VS Code is really recommended in dealing with software like Moose. Is basically you will have access to different things at the same time. So this is an example of Moose input file that we will talk about later. So I can here see and edit and modify this input file, but I can also here see my terminal, and I can basically run commands from here. So I can run any commands from here if I want to. And to do that, you will go here to those four square and look for extension. So two extensions that we need is WSL1. So I have this one already. So make sure you get the one by Microsoft. And once you basically install that extension, you will see that down here, it already recognizes that basically my terminal is working on Ubuntu. So it basically now make Ubuntu as my default terminal. So every time I am working with VS Code, I have already direct access to my Ubuntu terminal. So once this is the default setup, you should see the WSL Ubuntu here. The another extension that we will need for Moose is basically the Moose language. So this extension, again, that's I already have installed, so I don't need to install it. So this is the one by Daniel Schwen, and this will help us in basically reading and editing and modifying input files. So it recognizes basically the different blocks and different functions in Moose, and it will basically show a nice color, a nice contrast between different blocks and between different aspects and features within each block of the code. And also it has some nice features like basically autocomplete. So basically it can autocomplete different blocks in a Moose input file. All right, so let's go back to our presentation. So again, the WSL extension inside VS Code give us direct access to basically the Ubuntu. And then once you have that, you can pin it to your taskbar, like what I have here. So now my VS Code is always available for me basically under my in my taskbar, and it also by default recognize Ubuntu as my default terminal. You can always, if you don't, for any reason, if you don't see the terminal down there, you can always go to the view from the menu here. You can always go to view, and then basically you can get a terminal. All right, so that's it for the VS Code, really. Uh, then the second step, so basically now we finished the first step, the WSL and Ubuntu and VS Code. Now the second step is to install Moose itself. And to install or set up Moose, so those are kind of two different options. So there are two ways, basically. We are going here to follow the simple method, which is basically to set up a pre-built or a pre-compiled version already. So basically, the advanced way would be to install Moose from scratch, and that's important for basically people who are doing advanced research. So if you think you will need to change or modify things within Moose or add to Moose to be able to do your research, then you will need to work with basically a complete version that you built on your own, or if you wanna basically make your own application that is built upon Moose, then you will do that. However, for most purposes, especially for teaching and learning, the pre-built version is basically all we need because we will not add new capabilities. We will just utilize the capabilities that's already existing. So to do that, we're gonna use this pre-built or pre-compiled version. And this is, we can directly go from this link or from the Moose website. I wanna show it to you on the Moose website so you basically know what we are doing. So basically, if we go to the Moose website, you can always go to getting start installing Moose. And that's here what we talk about. So basically, we are going to utilize the pre-built Moose, which is excellent for training. So the Conda pre-built Moose. So this is basically to install this pre-built version. So we already installed or enabled WSL. So the first thing is to basically install the Conda environment, which we will use to, which is basically an environment manager that we will use to set up the Moose package. So this depends if you have a Mac, then you will go for the Mac version. If you have basically a Windows or Linux, you will go to the Linux version. So even if you have Windows, we set up the Windows subsystem for Linux. So we are basically using a Linux terminal now. So we'll use that for Windows once we enabled WSL and Ubuntu on Windows. So from here, it is safe as opposed to if you copy and paste from a file. From here, it is safe to copy and paste. So you can basically just hover over the mouse here and click copy to copy those commands. I already have Conda on my machine, so I don't need to do that. So I have basically I have ran those two commands already. Then you can basically follow the commands up till a specific point here. So we're gonna go over that. So I have basically enabled the Conda already. So this first step I have already done. So I don't need to install Conda or enable it. This is already have been done. What I will need to do and show basically so you can follow is starting from installing Moose here. So you will follow all those commands. The first one will depend on you have a Mac or Windows. Then those 4 or 5 commands, you will follow those one at a time. And then here basically where we install this pre-built version of Moose. So we can just copy and then go to our terminal and paste. So this is creating or downloading the Moose package or the pre-built Moose version. You can see that it's getting the Linux version here and it is collecting the data. So this is download. So you'll have to, of course, be online to be able to do that. So it will take a few seconds or a minute. It will ask you basically to proceed, so you have to confirm that. It's downloading. All right, so download is done. So our next step is to basically activate Moose. That's what was recommended anyway, as you can see. So now we have the Conda environment. So initially, if you don't have, usually your terminal will start with the base environment. If you don't have any other environment, then Conda would be the only new environment you have. But you could have several environments, the same machine. And that's the advantage of those basically environment managers like Conda, that you could have different software and different libraries on the same machine without basically any overlapping between those environments. So now when we activate this new Moose environment, you can see that it changed from base to Moose. So now we are on this Moose environment. We can then go back and keep following things here. So we're gonna make sure that Moose was basically downloaded properly. So we're gonna see if we run this Moose help command that it does recognize it. So we're gonna go back to the terminal here. So you can see if we do Moose help, it does give us basically different commands and options that we have. So basically it does recognize the command and basically it shows that we downloaded things uh, properly. So now we want to make sure basically to start running examples and things like that. So here we're gonna make a little bit of a change. So starting from here, we're not gonna follow the instructions on the website, and I will explain to you in a minute that why this is the case. So we are going to follow the instructions on the slides instead. So the slides initially were basically following the same instructions that we have done in enabling the Conda environment first, and then basically downloading the pre-built version of Moose. So those commands are just basically copy and paste from the website, depending on whether you have a Windows machine or a Mac. However, so until Moose help, we are following everything, all the instructions from the Moose website directly. However, the last couple of instructions, those would be a bit different from the Moose website because we wanted to basically not just on the Moose website, they just give an example of a specific physics modules. It's the heat transfer module to basically copy it locally so you can modify things and input files and run things locally without changing the original sources. But instead of copying just the heat transfer module, we're gonna copy the more generic combined module. So the combined module have access to all those physics modules, whether it's heat conduction or solid mechanics or basically fluid flow or fluid mechanics or basically microstructure evolution, all of those different modules, all of them can be accessed from the combined module. So the combined module is necessary to run multi-physics simulations. So that's why we are going to copy the combined module instead of just the heat transfer module. So basically, we're gonna follow those commands so we can copy and paste those. So that was the first command. So we made that projects and examples folder. Then we're gonna go inside that example folder and copy that combined module. So here we can also print the working directory. So we can also list. So see, so now we have created, so the Miniforge folder will be created once you follow the commands to install the Conda environment. The project folder is the one that we just created. So if we go inside that, see we have the examples folder. And that's where we wanted to copy this combined module from the original Moose folder. So we're gonna do this. So you can see it copied locally. So it copied from this original folder. Now, if we do that, we see that is now there is a local Moose folder and there is a local combined folder, and you can see the combined will have its own tests folder. So now to make sure everything's was basically were done properly and this combined module has everything, we can basically run the tests. So Moose comes with its own tests to make sure that basically things have been compiled properly on your machine. So here we can run this command to make sure basically that things were compiled and downloaded and compiled properly. You can use many cores, so this is the number of cores. You can use as many as you have. So you can see it's running different tests. And you can see since we used the combined module, you will see multi-physics. So there is some tests in heat transfer, some tests in solid mechanics, and things like that. This will also take like a minute or so. some tests could be skipped because just the number of cores, sometimes tests need higher number of cores or there are some different configurations. But the important thing is that basically no test should fail. So all tests should pass. So you can see here, so it ran 211, all of them passed, 49 were skipped, and 0 was failed. So that's a successful installation or setting up of the framework. Now, if there, in general, there are a very basically well documented and well established discussion forum. So if there are some strange errors, you can always, of course, first basically look it up, especially now with the AI tools like ChatGPT or Gemini, it should give you some hint. But also, if there are some kind of strange errors, you can always try the discussion forum on GitHub and on the Moose framework. So the last thing, so basically now we installed the VS Code, we installed Conda and Moose. So we will use the VS Code to look at input files and modify them. I'm gonna talk about that in the next video. But the last thing that we wanna install so that we have the entire basically workflow that we need from editing an input file to running a simulation to visualizing a simulation. So the last piece of the puzzle to basically visualize the result of the simulations, to do that, we will have to use a visualization software. There are two different types of basically outputs that Moose can generate. So it could generate basically CSV files, where basically that's basically something like a post processor, like calculating something based on the solution all over the mesh. So in that case, basically you can visualize it by anything, but still you cannot visualize it also using ParaView, which is the software that we'll use. But ParaView is necessary to visualize the mesh, basically where a finite element mesh you are solving the BDE on a discretized mesh. It is representing some geometry, and to get the solution everywhere at every point on that mesh or every element on that mesh, we have to use basically a visualization software. And the best open source visualization software is definitely ParaView. So ParaView, if you go to their website, it should be able to recognize your operating system and basically give you the correct uh, download page. So if we go to the website here quickly, so you can go to the, of course, the homepage first. So this you can read a little bit about ParaView. So it's definitely the most powerful open source visualization software. It has been there for more than 20 years now. It has started as a collaboration between a few national labs and the Kitware, the company. And basically, that's the software of choice in visualizing basically solutions of BDEs using finite element or finite volume software. So you can always go to the download page from here. Should be mm, so it will recognize, so in this case, it's recognizing that I have a Windows machine, so it's basically asking you to pick a specific version based on Windows. You can pick the latest one for what, however, keep in mind if you are going to use the one with MPI, then you will have to install the Microsoft MPI first. So MPI is important to run things in parallel as we have done when basically enable this feature for Linux. But for ParaView, if you want to also utilize or take advantage of the fact that your computer has more than one core, so you can also use this computational power in helping you processing the data and visualizing the data with ParaView. So you can get the basically the MPI version of ParaView, but to do that, to enable that on Windows machine, you will have to first enable the Microsoft MPI. So this is also an application that you will get, so you can download it from here and just install it like any application from the web. So this is straightforward. I have already done that. Once you do that, then you can pick basically the MPI version where basically you can install the usually, it's the easiest is to just use the .msi, so the Microsoft installer. So this version, so if you didn't enable the MPI, then you will get the version without the MPI. If you enable the MPI, then you get the version with the MPI. So I have already done that. So basically, you can uh, look at basically, so this is how ParaView would look like. So basically, I have already installed it, so you can just open it, and we're gonna discuss in the next video how to basically utilize and utilize ParaView in basically visualizing the results from those. So in the next video, we're gonna open a mouse input file using the VS Code, run it through the terminal, and then go to the output folder and basically upload the output files here to ParaView and use ParaView to visualize the results from the output file. All right, so that's all we need really to be able to do everything from reading or editing an input file to run it using the mouse through a terminal or through the VS Code to eventually visualize the output. And as we're gonna discuss in the next video, so ParaView would look like something like that. So this is a simulation of heat conduction in a UO2 pellet. And basically you can see that basically this is the mesh. This is basically a geometry of the circular pellet. And then you can also basically take like a line scan or line plots where basically you can see how the temperature is changing as function of the radius. So all of those features we're gonna discuss in the next video. One thing to keep in mind, if you are new to Linux, you can basically look up the kind of the most used commands and to run from a terminal, especially the ones that are needed to edit or modify different files or folders. So the command that you absolutely should be familiar with is basically to list things. So if you're inside a folder and you wanna look at basically the contents of that folder, so you can run ls. If you wanna change the path, so if you wanna navigate between different folders, so cd is for changing directory, so to go from one folder, from one directory to another. If you want to know where exactly you are, the path or the location to the current directory, you can run pwd for print working directory. Then you can copy if you want to copy file from one folder to another. So that's the command that you will use. If you want to move folder or files, you can use a move command. And then if you wanna delete or remove things, you can use the remove command. And some of those commands work with both files and folders. So something like remove, if you want to remove an entire directory or folder, you will use the flag -r for recursive. So this is to basically move or remove the entire directory with all the files inside that directory. And then there is one, however, that's missing from the list that we have already used actually while we are setting up the Moose package, which is to make directory, right? So we want also to make new directories. So if you want to make new folders, so that's basically the last important command. So I would say there is like 7 or 8 of them that you need to be familiar with. And once you use them a couple of times, you will always basically remember them. But of course, anytime with access to the basically AI tools, anytime you forgot the syntax or forgot the command or how to do things, you can always look it up very easily nowadays. All right, so this is it for this video where basically we looked into installing the important or the required things to be able to run a simulation using Moose, modify the input file, and change and look at the output. So those are the required things to either download or install. And in the next video, we're gonna actually show in action how we are actually using those. So we'll demonstrate the workflow. We will run an input file, modify it in VS Code, and then visualize the results in ParaView. So I will see you in the next video.